So this is an example on Newtonian gravitations. Now the questions is given as shows. A three billboard balls with a mass of 3 kilograms are placed on a table at the corners of a right triangle as shown in figure. This is the figure. So questions A asks you to find the net gravitational force on the cue ball, which is in this case is our M1, resulting from the force exerted by two balls, which is our M2 and M3. So to solve this one, I have to know that the force that exit between M1 between M2 due to M1, we call it as F21 with the length of A, and the force exit on M3 due to M1 is equal to F31 with the distance of B. Now, I know that the resultant force between these two will be placed in here, which is, I call it as an F. So I have to find the value of this one by substituting the value or by solve it using the equations of gravitation, which is this one. We did learn this one in our lecture video if you already watch it. So this is for F21, which is on this one. So force that exert on M2 due to M1 is equal to F21. Now, given the value of G, which is, this is a constant value, and the mass of M2 is equal to 3 kilogram, and mass of the M1 is equal to 3 kilogram too, and let's say the distance of A is equal to 0.4 square, so the value of F21 is equal to 3.75 to the power of negative 11. Now, repeat this step for F31. By substituting everything into these equations, I will get the value of F31, which is equal to 6.67 to the power of negative 11 Newton. So this is the value of 31 and 21. Now, to find F, which is our resultant force, we will apply the rules of Pythagoras, which is this one. So F is equal to square root of Fx squared, which is in this case our x-axis, force that exit in x-axis is equal to F31, which is equal to 6.67 to the power of negative 11. We plus it with the F that exists in y-axis, which is in this case is equal to F21 with the value of 3.75 squared. Substituting everything and calculate it, you will get the value of F net, which is equal to this one. So this is the value of F net. But then I don't know where is or which or how many angles that this force from the y-axis. So I have to find the directions of it. So to find the directions, I will get these equations or use these equations, which is, I believe you are quite familiar with it. So substituting everything again, I will get that the value of theta is equal to 29.3 degrees. So this force here, which is our net force, is equal to 7.65 to the power of negative 11 Newton, are located between x-axis to the F resultant with the degree of 29.3 degrees. So that was questions A. Now, using the similar equations and similar figure, question B asks you to find the component of the gravitational force of this force or this ball due to this ball. So our F is equal to F23. So to find F23, I will get or I will use again these equations. So by, let's say the distance of 23 is equal to 0.500 meter. So the value of F23 is equal to 2.4 to the power of negative 11 Newton. So you were asked to find the component, means you will need to find F23 in x-axis and also in y-axis. So to find that one, I have to first and foremost calculate the value of theta between the positions of this hypotenuse to the x-axis and y-axis. So I will get the cos theta is equal to 0.6 and sin theta is equal to 0.8, which is this theta is in the position in here. So my f23y axis on x-axis equal to supposed to be equal to this one, and the f23 in y-axis is supposed to be equal to this one. So the position of this f23x is equal to this position, and the position of f23y is supposed to be on this position. By the additionals of between these two, I will get the value of f23. So that's it on the example on Newtonian gravitation.